Graphs and networks, bipartite graphs. So bipartite graphs are often used for allocation of one group of people or objects to another group. So by two, the vertices belong in two separate sets. So matching players to from two different teams to play each other or something like that. And each edge in a bipartite graph joins vertices from one group, or a vertex from one group, to a vertex in the other. So here's an example of an allocation problem. These 5 people with useful alphabetic names are presenters on a TV travel show, and each presenter will be filming a story about one country that they've previously visited. And we have all the information about which countries they've visited, and an allocation or assignment problem is to work out who needs to do what. Now we could just think this through. You know, Angie's visited Senegal only, so Dorian can't visit Senegal, so he must visit Myanmar. But once it gets a bit more complicated than this, we really do need to have a diagram so we can keep track of everything. So doing an assignment bipartite graph makes the most sense. So your two groups are presenters and countries. So we've got Angie, so there we have group 1 of vertices, and over here we'll have our countries, and we'll just put them down in the order that they arrive on our page. So I've got Senegal, Vietnam, Peru, Ghana, Myanmar. All right. Now there's a couple of different ways of approaching this. You can start by drawing the whole graph of where everyone has visited and then start ruling out places on the same graph, or you can copy the graph and add more lines in. We'll see how we go. Firstly, we'll just get where everyone's been. Angie has been to Senegal. Bev has been to Vietnam and Peru. Charlie has been to Ghana. Sorry about getting a bit wonky there. And Peru. Dorian to Senegal and Myanmar. Evelyn to Vietnam and Myanmar. Now, I did that in purple, so we can, if we want, put the definite assignments over the top of this in black, or I could redraw Angie, Bev, Charlie, Dorian, Evelyn, and the countries, and just put in the definite assignments. It's up to you. Angie has to cover Senegal because it's the only one of the 5 she's been to, which means Dorian cannot visit Senegal. Dorian's only other choice is Myanmar, so we put that in. Then we'll look at who else could have done Myanmar. That was Evelyn. He or she, it's a gender neutral name there, can't do that, has to do Vietnam. That means Bev, who could have done Vietnam, can't do it. Bev has to do Peru. This is a lot easier, really, to draw this up than to keep all this in your head. Charlie could have done Peru but can't now because Bev's doing it, so Charlie ends up with Ghana. So while there seemed to be a whole bunch of different options as to where people could go, when you took into account all the restrictions, there was only one possible way of assigning it. And then if you get asked to work out who's going where, you would say who goes where. Angie, Bev ended up with Peru. Whoops. Charlie, where'd Charlie go? Ghana. And so there we go, a bipartite graph helping us solve an assignment problem. As I said, we could have done this as one graph in purple and then done a second copy and just done the black lines, or working over it like this. It's up to you how you feel you're most likely to get the right answer.